Hello everyone, I am Punit Lohia and today I am going to discuss about an interesting system which is helping Ethereum users to minimize their cost and increase their efficiency known as Arbitrum in just 20 minutes. Before starting with Arbitrum, first let us discuss about transactions in Ethereum. Ethereum is an incredibly popular platform for developing decentralized applications. Any application running on Ethereum is implemented via smart contracts. Smart contracts are simply programs stored on the blockchain that run when predetermined conditions are met. They typically are used to automate the execution of an agreement so that all participants can be immediately certain of the outcome without any intermediaries' involvement or time loss. They can also automate a workflow triggering the next action when the conditions are met. Any interaction with or between these contracts is called a transaction. Because it mainly incurs a fee which is used to reward network participants who maintain the blockchain and house the smart contracts on their machines. As the number of contracts and user grows, the Ethereum networks need to process more and more transactions, which does not come for obviously for free and leads to higher transaction fees as well as slower execution. While some people believe that the best way to scale Ethereum is through on-chain tweaks and upgrades, others are still pursuing different routes known as second-layer solutions. Though these vary significantly in their form and function, one such solution, known as Arbitrum, has begun picking up considerable momentum due to novel solution to the problem. Now, let's first know what is an Arbitrum. Arbitrum is a system which allows Ethereum participants to settle their transactions away from the Ethereum mainnet. It is compatible with established applications like Curve, MetaMask, and Aave, with many more which are on the way. Once executed, transaction data is sent back to the Ethereum blockchain, so everything is stored on the mainnet. Arbitrum is a layer 2 solution designed to improve the capabilities of Ethereum smart contracts, boosting their speed and scalability while adding in additional privacy features to boot. So basically, Arbitrum is a system that works on the existing Ethereum networks. So now let us discuss how Arbitrum and Ethereum work with each other. The platform of Arbitrum is designed to allow developers to easily run unmodified Ethereum virtual machines known as EVM contracts and Ethereum transactions on a second layer while still benefiting from the Ethereum's excellent layer 1 security. It's built to address some of the shortcomings of current Ethereum based smart contracts, such as poor efficiency and high execution costs, which have damaged the Ethereum's user experience and frequently to make transaction an expensive task. Arbitrum begins with ETH a set of smart contracts on Ethereum which connects the Ethereum with Arbitrum's network called Arbitrum Virtual Machine, also known as AVM. If you want to submit a transaction through Arbitrum, you simply send it one of the ETH contracts called inbox. For reverse transaction, there is an outbox contract which receives data from Arbitrum and adds it to the Ethereum blockchain back. All inputs and outputs to ETH are public and verifiable, so Ethereum knows and verifies all the off-chain activity. Let us discuss about rollups. Rollups perform transaction execution outside layer 1 and then the data is posted to layer 1 where consensus is reached. As transaction data is included in layer 1 blocks, this allows rollups to be secured by native Ethereum security. There are two types of rollups with different security models: optimistic rollup and zero knowledge rollup. Zero knowledge rollup, also known as JK rollup, runs computation off-chain and submits a validity proof to the chain. Optimistic rollups assume transactions are valid by default and only runs computation via fraud proof in the event of a challenge. Now, all rollups handle transaction execution off-chain, meaning they use their own structure to facilitate transactions. In this way, rollups are like decongestants for Ethereum. They relieve Ethereum by readily supporting Ethereum-based activities like would have otherwise computed for L1 Ethereum block space. Like as you can see the layer above the on the Ethereum line, and downside there is rollup happening. Rollup execution execute transactions off-chain, but in some capacities, these L2s post data to the Ethereum mainnet. How do they determine whether they are a JK rollup or an optimistic rollup? The former relies on the validity proofs, which entails posting batches of transactions by cryptographic proofs called JK snarks. The latter relied on fraud proofs, which assumes posted data is valid unless challenged. Arbitrum is a type of technology known as optimistic rollup. It allows Ethereum smart contracts to scale by passing messages between smart contracts on the Ethereum main chain and those on the Arbitrum second layer chain. Much of the transaction processing is completed on second layer and the result of this are recorded on the main chain, drastically improving speed and efficiency of the Ethereum network. It's optimistic in the sense that any validator is able to post a rollup block and confirm the validity of other blocks. While the term rollup is used to describe how public information can be used to reconstruct a complete history of the chain from optimized log of events. The, arbit- the Arbitrum protocol ensures that the code will run instantly so long any validator is honest, helping the network resist collusion and other form of attack. Future versions of Arbitrum will are also going to have two other modes, channels and antitrust sidechains. As with many blockchain, individual nodes can choose to participate in the Arbitrum chain. Validator nodes are involved in observing the state of the chain and full nodes help to aggregate layer 1 transactions. Aggregators that submit transactions to the layer 1 chain earn rewards paid in Ethereum, while the rest of the users' fees are distributed to other network participants such as validators. Arbitrum also introduces a challenge step for rollup blocks, which sees other validators check the correctness of a block and issue a challenge if they believe it is wrong. If the block is proven to be incorrect or challenge is proven unjustified, the lying validator will have their stake confiscated, ensuring validators always plays fair or risk the consequences. The platform has its own custom virtual machine, aptly named the Arbitrum Virtual Machine as we discussed above. This is the execution environment for Arbitrum smart contracts and exists above the ETH bridge, the set of smart contracts that interfaces the Arbitrum chain. Ethereum compatible with smart contracts are automatically translated to run on this AVM. Now, let's talk about what are validators. Validators in Arbitrum are the parties who take responsibility for keeping track of a smart contract and make sure it executes correctly. Not everybody is a validator in Arbitrum, since some nodes simply compute the correct state of the chain for their own record. However, anyone can become a validator in Arbitrum by running an open source code from their local machine. Some validators decide to stake their Ethereum, which allows them to propose a new rollup blocks. If such validator is found cheating, a portion of their stake gets burned and some is distributed among honest validators. The size of a required stake is changing dynamically to make sure that a malicious validator will be able to cover the losses of compromised blocks. Non-stack validators are also called watchtower validators. They do not take active part in block formation but merely observe it and alarm activates validators if they notice a malicious behavior. There are two ways you can use Arbitrum. Which one is right for you will depend on what the contract does and who is using it. If your contract has fixed size of participants that is run to less, like we can say around less than 15 participants, or if you want to keep the internals of a contract secret, then you probably want to use an Arbitrum channel. If you put more importance on openness and scale, especially if you want trustless execution with many potential participants, then you want an Arbitrum chain. Now let us discuss about Arbitrum channels. Arbitrum channels are like state channels, only better as with state channels you identify in advance a fixed set of validators for your contract. If your contract has a fixed set of participants, you will probably make all of them validators, then the contract will execute trustlessly. Alternatively, you pick a set of validators who are widely trusted and rely on Arbitrum's any trust guarantee, which tells user if they trust any of the validator, they can trust to contract execute correctly. Channels are the most efficient way to use Arbitrum. Your contract storage and computation are both off-chain, but Arbitrum guarantees trustlessness even for the off-chain component. You will touch the chain only when your contract needs to make or receive on-chain payment, or in rare cases if your validator goes offline or is defective. Your transaction will have an instant finality. Quick response. Arbitrum quick channels are better than straight channels because they are much more resilient against unavailable or defective validators. If a validator has any trouble, a traditional straight channel solution would have to move your entire contract on chain, which would be very expensive. So expensive that you can't practically use traditional straight channels except for contracts that fit on chain. By contrast, Arbitrum channels touch the chain only very lightly, even if a validator has trouble. The vast majority of a computation and storage stays off-chain no matter what. Now, Arbitrum chains. If Arbitrum channels doesn't meet the needs of a contract, you will probably want an Arbitrum chain. In this approach, your set of validators is not fixed and your contract activities are public. Anyone can become a validator simply by submitting a stake to database behavior. A validator can quit and get back their stake at any time. Although there might be delay of an hour or less to get their stake back if they are currently accused of bad behavior. With an Arbitrum chain, your contract's computation and storage are still handled off-chain, but all messages to and from your contract, that is, the transaction requested of it and their results, are on-chain message data. Anybody who follows the contract can keep up on its state. This requires the same trust assumption as a normal Ethereum contract, but it's more efficient since the computation and the storage, which are the most hectic tasks, are off-chain. Now let us discuss about what is an Arbitrum token bridge. The Arbitrum token bridge allows users to migrate ETH and ERC20 Ethereum tokens over for an use on the Arbitrum 1 network, which uses the Arbitrum method. The process works like so. First, you need to add the Arbitrum 1 network to your MetaMask wallet. Then you need to head to the Arbitrum token bridge and connect your wallet. Now you need to select which assets you want to keep over the bridge. After that, you need to type the amount of Ethereum or token you want to bridge over. Now you just need to press deposit and finish the deposit transaction, and woo, you will be done. Now there is a slight issue there. You can migrate your funds back to Ethereum using the bridge whenever you want, but these transactions will be subject to a 7-day withdrawal period due to current design limitation of the optimistic style rollup. So this is one of the drawback of the optimistic style rollups. Let us talk about how the Arbitrum arrived. In May 2021, Off-Chain Labs launched the mainnet beta of Arbitrum 1, but it was only available to the developers and their beta testers. On 31st August 2021, Off-Chain Labs announced the official launch of the highly anticipated Arbitrum 1 mainnet. A number of top decentralized finances such as Aave, Balancer, Band, Protocol, Curve, SushiWeb, and Uniswap are already leveraging or looking to use Arbitrum to increase their throughput and also that they can reduce their cost for their users. Off-Chain Labs also announced that they have raised $120 million in a Series B funding round led by Lightspeed Venture Partners. This gives the company a current valuation of $1.2 billion. Other notable investors in off-chain labs include Coinbase Ventures, Pantera, Compound, and BlockNation. Let us discuss about the features of Arbitrum one by one. It has several distinctive features like high EVM compatibility. Arbitrum is considered to be the one of the most EVM compatible rollups or Ethereum virtual machine compatible rollups. It's compatible with the EVM at the bytecode level, and any language that can compile to EVM works out of the box, such as Solidity and Viper. This makes it very easy for the users to develop, and since developers do not need to get to grips with a new language before building an Arbitrum. So basically you don't need to learn any other languages to use Arbitrum. Now, second feature can be robust developer tooling. The team behind Arbitrum are doing what they can to minimize barriers to entry when it comes to building on their layer 2 solution. As such, they have produced comprehensive developer documentation for Arbitrum, and the developers can start using the existing tooling for Ethereum. There is no need to download anything specific to Arbitrum such as plugins or compilers like Hardhat, Truffle. So basically you don't need to download any other thing for the Arbitrum network to use. Third feature is low fees. As a layer 2 scaling solution for Ethereum, Arbitrum isn't just designed to boost Ethereum's transaction throughput, but it also minimizes the transaction fee at the same time. Thanks to its extremely efficient rollup technology, Arbitrum is able to cut down fees to just a tiny fraction of what they are on Ethereum, while still providing sufficient incentives for validators. Fairly launched, Arbitrum has run several testnets since October and was live on mainnet only for developers. Unlike many other layer 2 scaling solutions, Arbitrum doesn't have its own native utility token, hence there was no token sale. Moreover, all interested developers were given time to get up and running before Arbitrum was open up to the masses. Arbitrum also pledged to give all 250 plus development teams that applied to build on the developer mainnet at least 2 weeks, 2 full weeks of development time before opening Arbitrum 1 to everyone so that they can get a first mover advantage. Well developed ecosystem. Arbitrum is already working with a wide variety of Ethereum dApps and infrastructure projects, including the likes of Uniswap, Dodo, Sushi, and dozens of others. Now, let us talk about the risk of the Arbitrum network. Arbitrum is ultimately a smart contract chain so that its user fundamentally face smart contract risk, that is, the risk derived from the possibility of losing money due to unforeseen smart contract bugs or economic flows. As for early fiction, we have recently mentioned the Arbitrum 7-day withdrawal period. That's much longer than users care to wait. But it's an unavoidable reality of young optimistic roll-up systems. The good news is that going forward, cross and interoperability solutions like Hope Protocol will popularize fast withdrawals from projects like Arbitrum. Additionally, low liquidity in dApps is for another friction early Arbitrum users have been facing. It's an understandable difficulty at this point, considering how Arbitrum 1 is just beginning to compete for liquidity from other L1 and L2 liquidity. Now, now let's talk about Arbitrum token. Arbitrum doesn't have a token. If you see anywhere offering anything related to the effect of an Arbitrum token for trading, it's a scam. Mark my words, it's a scam. That's because Arbitrum doesn't have a native token. The roll-up transactions are paid for in ETH, and Option Labs currently have no plans for a bespoke Arbitrum token. I would like to conclude my presentation and thank you and have a nice day.